Okay, ladies and gentlemen, welcome back. This is PN42 Part B on polar coordinates, but now we're going to actually get away from just plotting the points and plot some polar equations. You'll find that they're a little bit interesting to plot. So I'm going to start with just kind of getting some general looks to some of the graphs. Right here, as it states, I'm going to try very hard to get this bigger. It says, because we are graphing in our new coordinate system, all equations are in terms of r, r and theta. So it's going to look different. It's definitely going to feel a little different here. And let's just focus on this first to start with. There's two basic polar equations. The first being where it's theta equals some sort of constant. And so this right here just means constant. K typically does stand for that in math, so constant. So it could be theta equals pi over 3, pi over 6, whatever. Let's just say the constant is this rotation right here. So the directional angle is right there. And we're talking about that all points at that directional angle. So really, when you see something like theta equals k, or theta equals some sort of constant, you're actually talking about a line. So that's kind of cool because we've done lots of different lines before. So that is definitely theta equals, let's say, pi over 6. I bet before today you would not have thought, hey, that's a graph of a line. R equals k. That's going to be just a little bit different because, again, k is a constant, just like on the other side, constant. And let's say you have r equals 3. Well, you'd come out 1, 2, 3, and you would want to make sure your radius all the way around the center is 3. So I'm just going to say it's k though right now, but just for your notes. But really, any kind of r equals a constant is going to be a circle. So let me kind of keep that going here. And I'm going to try very hard to zoom it so I can draw in a way that's not horrible. So if we want to graph, let's say theta here equals pi over 3, and I'm going to box this in so you know which one I'm graphing. That means that we're going to rotate pi over 3, and if you need to, you can do your little, this is pi over 6, this is pi over 3, pi over 2, and go all the way around the circle. And pi over 3 is obviously right here for the rotation, and we're talking about a line at pi over 3. Now note that theta equals pi over 3, that line is going to be, if you drew your rotations all the way around this is 2 pi over 3, 5 pi over 6, pi, almost there, 7 pi over 6. Here's 4 pi over 3. Now think about this. If you said, hey, I want you to graph theta equals 4 pi over 3, that's going to be the same thing as the graph of pi over 3. So keep in mind there is some interesting phenomena like that you want to kind of take note of. So if we switch, I'm going to switch colors because I can. I'm going to graph pi, theta equals pi. So I'm going to rotate all the way over to pi and draw my little line. Because any rotation or any point on that rotation of pi. And then you can do the theta equals 4 pi over 3 right now, just to double check that you have figured this out. And of course, now that I look at it, I kind of ruined it, right? Because I already told you that pi over 3 is the same exact thing as 4 pi or 4 pi over 3. So of course you're going to rotate with the red 4 pi over 3, and then you're going to graph the line, and you're like, oh, it's the same thing. And yep, it is. Okay. Anyway, so that's really one of the common shapes. Another one is, bear with me here. I'm going to move this over so we can kind of look at it, is, of course, that circle one. So there's just one part that's kind of a little bit weird with this, and it ends up being that letter C one where it's r equals -6. So you can graph r equals 3 really quick, r equals 2, obviously those are circles with a radius of 3, and then another circle that has a radius of 2. So without talking too much, I'm going to do that super fast. So I'm going to do this one, 1, 2, 3, and then you check your note guide with mine, of course. There's that. And then I'm going to switch colors just because, now if you are not switching colors with colored pencils or something like that, you make sure you label your graph. So I would have put like, actually I probably shouldn't have done the purple, right? But if you're graphing, let's say r equals 2, 1, 2, and I'm doing it in purple, so that's kind of like my legend over there, so you can kind of see it. But if you're not doing that, you need to make sure you label your graph. So that's B, and then this is obviously the A graph. So it's kind of important to denote which graph is which. Now the one that I need to talk just a little bit about here is this r equals -6, because you're going to be like, how can I have a radius of -6? Well, remember when you had that point, let's say -6, I don't know, pi over 2, so 90 degrees. Well, if you went around and rotated to pi over 2, which is right here, and then graphed that point -6, you're actually going reverse or away from that pi over 2 angle. So 1, 2, 3, 4, 5, 6. You're going to end up right there. And you can continue doing that. Like for instance, this point right here could be denoted by -6 pi. Now, of course, it also is 2 pi or 60 radians, but the reality is that you could represent that in multiple ways. So whether or not you're talking about -6 radius, it ends up being, oops, I counted right here, 1, 2, 3, 4, 5, 6. Yeah, I'm off just a little bit here. I'm gonna go all the way around. Okay, so as it shows at the very, very bottom, equations of this form, theta equals k is going to make a line, as I mentioned, which is super, super cool. So anything that looks like this is going to be a line, and anything that looks like this is going to be a circle. Okay? Why are we excited about this? Polar coordinates and polar equations? Well, here's the thing. I'm going to shut my door first because obviously we're between bells. Okay, I'm back. It's because they're cool. Like when we're dealing with functions, well, you have lines and absolute values. So V's, if you want to think of it fancy. Excuse me, and all those kind of things. But we've been dealing with those for so long that it's kind of nice to shake it up a little bit. So seriously, it's kind of fun. So we're doing this not only to get some exposure to different graphing systems, but to have a little fun. Anyway, here are some of the shapes, general shapes that you're going to run across. Lemon skates. This one here, you're going to want to say lima. I don't know how people pronounce it, all sorts of different ways, but it's actually limassone. So this one's pronounced limassone. And of course, roses. Oh my. Get out the graphing calculators. You definitely need to change a couple things in order to graph these. So the first thing is you should never ever, when you're dealing with polar equations, have a y equals in your y equals. You should actually have an r equals, which is the radius equals. Okay, so that's kind of like your dependent variable. And the mode should be in radians, just like parametrics needed to be in radians. And you definitely want to have your mode now in polycoordinates. You do not want polar coordinates. You don't want it in parametric, and you definitely don't want it in function. The windows, this is really important. This is a starting point that I'm going to show you. Definitely to start, you might want to adjust it afterwards. But the theta, we definitely go from 0 to 2 pi, which is that full rotation. But the scale is really, really, really important. The scale, you don't want like pi over 6 because it's not going to give you enough data points to get a really good graph. You don't even want pi over 12. You're going to want pi over 24 to get a really nice graph. And I'm going to tell you, when you put pi over 24 or even 2 pi into your graphing calculator, it's going to approximate it to the nearest fraction or decimal, sorry. So just kind of keep that in mind. So your min is 0, your max is 2 pi, and your scale should be pi over 24. Your x, you should have it from -5 to 5, and your y the same. Okay, so you're doing that right now. And pause me if you need to pause me. And I'm going to just, over here while you're doing that, I'm going to put 0 here, pi over 6, pi over 3. And this is just standard coordinate. Sometimes polar coordinate paper has a different, they might go by pi over 4s or however they're going to do it. But just kind of keep in mind that you need to keep track of that a little bit. This one, we're going to graph this. Yay, it says graph r equals 3 cosine theta. So throw that in your graphing calculator. So you're literally just typing in where the r is, 3 cosine theta. And now if you, once you graph it, actually I should stop for a moment because there's kind of this cool like, whoa. It looks kind of like an ellipse. And you can definitely see that you have a point 0, 0 here, and then it's 1, 2, 3 right here. And I'm gonna kind of see if I can zoom in just a little bit. Great, we have announcements happening now, so just kind of bear with me. I'm going to also put a little table. I'm going to go into my table, and notice when you look at the table, it's going to be theta and the radius. So obviously, when we're dealing with the points themselves, it's written as r theta. But I'm just letting you know when you're looking in your table, it's not going to look like that. So what you're trying to do here is you're going to sketch a pretty good graph, an accurate graph, and then you're going to have to plot 2 and or 3 good points. So I'm going to plot 0, 3, which I already did, 0, 0, but it is what it is. You don't really use 0, 0 as one of your like good points if you want to think of it that way. And you may have to adjust your scale. Like for instance, a lot of times I switch my scale on my window to go up by 0.5s so that I can see a little bit clear what things are happening. So on just kind of I'm changing my X and Y scale to 0.5, and then I'm going to look at my table again. And when you look at your table now, you should be able to see that, and you can change, by the way, the good one to change is your steps. Well, you know what, I'll leave it at that. But you can do some tracing too, that's also very helpful. But you'll realize that, oh my gosh, that's so distracting. 1.53 is a pretty good point. So you're rotating 1.5 is right about there, and we're going to do this right here. And you're going to need to actually label those 0, 3, and that point right there, which is really hard with this stylus, 1.53. Okay, so down here, it says on every graph we must see. Now you're allowed a graphing calculator, except for maybe those basic lines and circles. You're going to be allowed a graphing calculator polars. And so you definitely need to give an accurate sketch. We expect that at least. And then one step further is we would want 2 points labeled other than that 0, 0 degrees. So, and of course they're saying degrees, but if we put 0, 0, it seems like we're obviously in radians. And it just really helps show the accurate sketch and reflect of the equation. So we just really need to have that in order to think that you're really doing something worthwhile here. Okay, so let's just do these two here, and then I'm going to let you go and try some on your own. It says r equals 3 sine 2 theta. So when you throw it in your graphing calculator, you will see, and I'm going to actually just give you a moment to do that, and I'm going to do it on my end, 3 sine 2 theta. Oops. Yep. Good. And you're going to probably ask what to do with the parentheses. The 2 theta is together, so if you want to close the parenthesis, that's fine. And you'll notice that you get this beautiful thing called the rose curve. So this thing is going to end up being called the rose curve. And that's kind of why it's cool. I think it looks more like a daisy, but we don't want to get all fancy about that. Anytime you see this where you have, and I'll put a general thing here, r equals like a cosine n theta, or r equals a sine n theta, you're going to end up with a rose. So any kind of thing that looks like this. And these are the general graphs. you know, just like we always say, like y equals x minus h quantity squared for perhaps, okay, anyway. And again, go into your table, and you can mess around with your table quite a bit. And what you can find is that if you go to 3, 1, 2, 3 on the outside, in the middle here, this is going to be one of your points. So 3 pi over 4. And this is where you may have to adjust your windows a little bit to allow you to see that. So you'll see, and another thing to mention, I mean, this is just something to think about, is that the most, because of that 3 in front of the sine function, it's like your magnitude almost. So that's as far out as this graph is going to go. If you look up that first one that we did, there's a 3 in front of the cosine. That's why the maximum, the farthest out as a radius it went was 3. Okay, so anyway, so we have 0, 0, and you can, again, plot all sorts of points here. You know, there's, let's see, 1, 2, 3, I'm trying to, 1, 2, 3, 1, 2, 3, it kind of does, ooh, I was off on this, was it? Well, I could have just, you know what, I'm going to change my scale. Now, that's the other thing that you can do, and you're probably going, oh my gosh, Ms. Bakken. The reason is because then I can get a much better graph. So I'm going to say that this is 1 right here, this is 2, and this is 3, because then I can get a really, really nice graph. And I'm going to go 1, 2, 3, and now they're going to start announcements just so you guys know, so just kind of bear with me as I try to beast through this note guide. 1, 2, 3, so yeah, it's going to be about here, coming down, same thing. So we've got one petal that looks like this right here, isn't that pretty? 3 pi over 4. Now, the great thing about roses is that we do definitely have symmetry, so you can do that same thing. 1, 2, 3, oops, 1, 2, 3 over here. Kind of draw that in. Ooh, geez, I could have done better. And this, of course, you keep going here. 1, 2, 3. And 1, 2, 3. So I do really kind of dig these. Ooh, that was not good. Oh, can I do better? I can do better. If you guys have a really good stylus that you recommend, let me know. Okay, so of course you have to plot at least 2 points. So I don't know. We can just do another one right here, which is going to be 3 and what do we got there? 3 pi over 4. Okay, and you can do 4 points pretty easily as you rotate around this thing. Anyway, so that's really the expectation. It's just to be able to draw a really nice graph, not, you know, if people are getting a little bit messy with it, I'm going to end up making them plot lots and lots of points. But just to avoid that, I'm just going to say draw a nice clear sketch, use the table in your graphing calculator as much as possible, and then label some decent points. So this will be the last one that I do with you all, and then I'm going to let you kind of go off on your own. Keep in mind that changing the scale on the graphs really does help if I don't know, I'm just letting you know, it kind of helps me anyway. Okay, so I'm going to put this as pi over 2. We know this is pi over here, and there's a reason I'm doing this. I'm just putting this over here, 2 pi over 3 and 5 pi over 6. And you want to graph this graph. And I'm going to tell you this is an awesome one when you graph it. It's going to be a limesone, and you know, it might help. By the way, this is a limesone with an inner loop, which is really cool. And if you haven't seen it yet, you'll see it. And I'm just going to put some phonics down here. Limesone. I think that's helpful. And any equation that looks like this right here, here's the general ones. R equals, so the radius equals 1 plus or minus b sine theta. And then or R equals a plus or minus b cosine theta. It's kind of nice to look at a graph and kind of know what it's going to look like before you even graph it. So if it's in this style, you're going to end up having something that looks like that. So I'm going to, hopefully you have paused me to graph this and what you would have found. And again, I'm going to scale this out a little bit. So I'm going to go, this is -1, actually it's 1. You'll notice how that works on here. I'm going to get rid of that. Because this is actually 1, 2, 3, right here is 3 pi, and that's one of the points on this limosone, and 2 pi over 3. That's a hard one to have noticed, and oh geez, bear with me here. And again, if you mess around with your scale a little bit, you have to recognize the approximations, the radian approximations as well. That's also the part that makes it a little challenging. But 1, 2, and at 2.3, there's the other one that I'm going to label. You can label other ones, it's all good. That's 2 pi over 3. And so this kind of goes like this. It kind of comes around, and I'm going to try really hard to graph this in there. And then it has an inner, ooh, where does it go? Yeah, right there. Okay, so it is a limosone with an inner loop. So cool. So if you kind of keep going with this note guide, I would like you to do the, for sure, I would like you to do this one, which just so happens to be the spiral. Oh, geez Louise, bear again. I'm talking too long. I need to wrap this video up, don't I? Spiral of Archimedes. And those are always in that form, r equals n theta. And if you look down here, these are the really fast ones that you can do without a graphing calculator, I would hope, using the front of your note guide. Oops. And then I would like to challenge you to do this one because it is super, super cool right here. So you're working or finishing this note guide. Notice at the very bottom it says you do not need to memorize the names of the graphs, and I cannot stress that enough. I just think it's super cool to at least know something that maybe no one else knows, and I don't know what I just did there. So you do not need to know the names here. I don't know what I'm doing. Right here, memorize the names of the graphs. Just know how to make them using the calculator, which is of course misspelled down here, and how to label the points. So again, minimum 2 points. Min 2 points, not including, of course, 0, 0. So the homework is going to be in section 6.5, sketch a graph for each, label 2 points besides 0, 0. And I'm going to say you're doing 4, 6. I actually, and you're doing the 25 through 35 odds, but don't do 35. Do number 35. 35 is kind of so you're doing 25 through 33 odds instead. Okay, so that is how you graph polar coordinate equations. Thanks for tuning in, you guys.